Hi friends, today we are going to see about the FIBG application delivery controller. So the FIBG IP application delivery controller. So what is an application delivery controller or an ADC? So let's see more about it. So just we'll take an example. One of our big bosses, we are working in United States of America, and one of the big offices over there, and one of the boss comes and meets us with a big smile in his face, and he says he got some extra budget to build some specific web servers. Well, we have to, the web servers is going to be optimized to work with clients that are connecting to the web server from an Android browser. So we're going to create a specialized web server to handle the content as it comes from browsers on all things like iPhones, iPads, so that they have an optimized experience on that platform. We're also going to create an additional server that optimized for people coming in from Windows if they are using Chrome. So the manager from the United States in the particular office is going to see saying like we are going to have specific web servers based on languages of the browser. So if a user is coming from a browser that indicates Hindi or Tamil or Japanese or Chinese, that language that the user is using, we are going to have a dedicated set of servers that include the particular language. So we continue on. So we're going to support additional languages as well. It's going to be great. Now the challenge over here is how to create the server that's optimized. For example, for a certain type of browser, and how to configure a server to support a specific type of language. What we haven't configured is how to identify, for example, the type of client that's coming in, and then making sure that the request gets to the correct server. So for example, an Android browser would go to like a server one, and maybe and it goes to server one, and another like an Apple browser, Safari is running on iPhone or iPad, and gets redirected to the correct server, and that's optimized for that browser. So where you would like I would get like we know like what we could do, we could put a device, for example, on one of the fi products, right, in this middle, in the between the clients who are making the requests and servers, and that have the answers and the content that users are looking for. So the device in the middle could do several things. So for example, we could direct or redirect specific requests to an application appropriate resource. For example, if we see the request coming in, and we can identify that it's coming from a specific type of browser, or we can identify that the browser supports a certain language. So the device here in the middle could direct that request to the appropriate server to handle that type of content. So the device in this middle could inspect that traffic or request, and it could transform the request to the responses coming from the servers as that traffic goes between the client and the servers. So the device also have the ability to verify the health and well-being of the servers to make sure they are up and available to respond to requests. And what we call like it's like a magical device between the client and the server. That's what's called that application delivery controller, and it can be used to manage the delivery of our apps and services. When we talk about application and services, let's think about some of the top applications that are on the internet today, like HTTP. So in case of the user trying to access some resource, this application delivery controller, based on the type of client that is coming in or the language specified, and virtually anything else regarding the request that being made, can be looked and analyzed, and the most appropriate resource it would be sent. So the HTTP is an example of one of the applications that we could use in combination with an application delivery controller to intercept, inspect, direct, or redirect the request to an appropriate resource. In this case, like one of these resources would be one of the three services on the backend. Another very popular application would be the HTTPS, which uses techniques such as the SSL or transport layer layer security, which has several benefits, including the ability to do authentication with what server we are really connected to, and secondly, with SSL TLS, we can build secure sessions that are encrypted. So anyone's eavesdropping on a packet as they go back and forth across the networks won't be able to identify what's in the payload of those packets because the content is encrypted, which provides confidentiality. Another huge application that used all on the time on the internet is the DNS, the domain name system. So in this domain name system, it allows us to go to any website, and it's the DNS that resolves the name into one or more IP addresses that a computer can then go ahead and use to connect those resources. So these are the examples of applications that are delivered over the network. So the application delivery controller, based on anything the request and knowing what we have as resource on the back end, or direct or redirect that traffic to the best resource, which allowed that server on the back end to respond to the client request. So one of the benefits of the application delivery controller is that if we have a lot of requests coming in, yeah, and we have multiple servers on the back end that all have, for example, the same web content that the request comes in, the application delivery controller could say, so it's going to go ahead and send the first request to server 1, and the next request it could go to server 2, and the third request it could go to server 3. It's a kind of a round robin fashion, in the application delivery controller could forward requests to the least busy server at the moment. So example, if server 1 and server 2 both had 100 requests they were currently servicing, and server 3 only had 50 requests, then it was currently handling. The application delivery controller, being aware of exactly who has been served up and how many requests, could go ahead and send that request to the device that has a current least number of connections and requests in process. So that goes back to this function of directing or redirecting the specific request to an appropriate resource. So in this example, the appropriate resource would be one of our servers that has the content and has the least number of connections currently in place. One of the most common terms that this divide could also be referred to as is called this FIBGP. They can be called as a load balancer. So it's assists in balancing the load across the multiple resources on the backend. However, the FI and the platform, they don't like us calling it as a load balancer. So the part of the reason is because FI product has the ability to do way more than simple load balancing on its platform, which is called Big IP. Big IP can physical appliance. Okay, so it could be a virtualized appliance running in a virtualized environment such as vSphere. So I'd feel like an application delivery controller such as an FI Big IP has the ability to direct or redirect specific requests to the appropriate server resources that can handle those requests. And in doing that, it has the ability to inspect and transform those requests as well as the responses that these servers are delivering to those clients. By monitoring the health of those backend servers, it can help reduce the risk of sending a request to a server that is not even up, which is at the end of the day. It's going to improve the end user experience in using the applications such as HTTP web services. So this is what the FIBGP does. That's the application delivery controller. It also helps us to do a load balancing as well. Hope this short video on FI load balancing, AFI the Big IP, the application delivery controller, and load balancing would be helpful for you. Like I've written some 2 books, like I've added those links as well. You can have a look on it if you are interested. You can comment on these, like we can have a discussion as well. See you guys.